Hello, boys and girls. This video covers section 5.4, comparing functions. In the previous section, we were writing equations for functions. In this section, they're going to give you two functions, and you will need to be able to create equations for both of them and then make comparisons. Like this one's going up faster. This one had a higher starting value. This one is going to be worth more at this point than the other one. Those are the kind of things that we're going to be talking about in this section. Your I can statement, I can compare functions that are represented in different ways using their initial values and their rates of change. We're going to be comparing the m's and the b's. Okay, so here we have an example, and this is what you're going to be faced with in this section. You've got two functions. One is in a table and one is in a graph. And you're going to have to make comparison statements about both of them. It says functions can be represented by tables, graphs, equations, or words. You can compare two functions represented in different forms by comparing the rates of change and the initial values. The rate of change is m, the initial value is your b, or your y-intercept. Functions can be compared to determine which is increasing or decreasing at a faster rate, or to determine which function has a greater value for any given input. So that would be like, well, after 4 days, which one's going to cost you more, kind of thing. The function represented by the table has a rate of change of 4, okay? Y is going up by 4 each time, whereas x is only going up by 1. So the rate of change of this is 4 over 1, all right? That would be the slope on this one. Let me fire up my pen. Okay, so for this function here, we know our rate of change is 4. And our initial value on this one, we'd have to back it up here. This goes down by 4, so this would go down by 4 also, okay? So the initial value, or your b, is 0 for this one. Over here for the graph, the initial value is 1, because that's where it intersects y. And the slope, or the rate of change, is up 1, right 2, so the rate of change is 1/2. Okay, so which function has a greater rate of change? Well, which one has a bigger slope number, 4 or 1/2? Well, 4 is bigger than 1/2. So if someone asked you which function had a greater rate of change, you would say this one does, because it's going up 4 each time. Okay. This, oh wow, there's a lot of blanks, and I always have trouble guessing what they want you to say in those blanks. We have a function 140h, where m is the miles traveled in h hours, represents the distance traveled by the first Japanese high-speed train. The distance traveled by a high-speed train operating in China is shown in the table. So this is the equation for the Japanese train, and this is how you would find the equation for the Chinese train, okay? So compare the function's initial values and rates of change. All right, well, let's think about this. We're talking about trains. If they have been traveling 0 hours, no distance has been covered. So the initial value for both functions is 0, okay? The rate of change for the Japanese train is this one, and the rate of change is this number, because this would have been your x. So 140 is the rate of change, 140 miles per hour. The rate of change for the Chinese train, well, if we started with 0, 0, how much is this going up each time? Apparently it's going up 217. So that Chinese train is booking it. It's going 217 miles an hour. That's pretty fast. So the initial values are the same, but the rate of change for the Chinese train is greater than the rate of change for the Japanese train. So part B, determine how much farther the Chinese train will travel than the Japanese train. Well, they're going to have to tell us in how long. Find the distance of the Japanese train by substituting 5 for h. So they're saying it's going to be traveling for 5 hours, okay? And they want to know, let me move this, put me right here for now, okay? So when we just take the equation and we're going to substitute 5 for hours. If you put 5 in here, 5 times 140 is 700. So the Japanese train can travel 700 miles in 5 hours. Okay, how far can the Chinese train travel in 5 hours? Well, they didn't give us that. But what we can do is we can keep increasing this each time by adding 217. So this next one would be 868. And if we added 217 again, we would have 1,085. Okay, so we know that the Chinese train can travel this far in 5 hours. The Japanese train can travel this far in 5 hours. What's the difference between the two? If you subtract those, you get 385, right? So this is what we're going to be doing in this section. They're going to give you two functions, and then they're going to ask you questions about them, like which one's traveling faster? Which one has a greater rate of change? Which one will be greater at this point, okay? Those are the kind of questions you will have to answer here. All right, so here we have a check. Suppose you decide which movie streaming service you want to decide which movie streaming service you should join. Company A, okay, charges $1.50 per movie with a startup fee of $5. The cost to stream movies from Company B is shown in the table. I'm going to write A as a y equals mx plus b, okay? Their rate of change, they're charging $1.50 per movie, so 150x, and x is the number of movies you rent, but they also charge a startup fee of $5, okay? This one, let's see if we can write an equation for this one. This is going up by 2, up by 2, up by 2, and this is going up by 4, up by 4, up by 4. So the rate of change for this one is 4 over 2, which is equal to 2. So Company B is going to have an equation of 2x, and the initial value, let's see if they have one. This keeps going down by 2, so the next move is going to be 0. And if this goes down by 4, then that would mean their startup fee is $4. So 2x plus 4 is Company B. So we have the equations. This is Company A, and this is Company B. Compare the initial values and rates of change. Okay, B is cheaper initially. It's $1 cheaper initially. Okay. Hang on a second. Sorry, wrong number. It happens to me a lot. People try to call Miss Williams, and they always get me instead. Okay, so B is $1 cheaper initially, but let's talk about the rates of change. A is charging $1.50 per movie, and B is charging $2 per movie, okay? So B charges more per movie, charges 50 cents more per movie. So part B, there I pretty well summed them up. I told you which one is charging more per movie and which one has a higher startup fee. How much more will Company B cost than Company A if you rent 15 movies? Well, here's Company A's equation, y equals 150x plus 5. And Company B's equation is y equals 2x plus 4. Now, you could, maybe do this here if you wanted to extend this, but it's going to get tricky because they want to know 15 movies, and this is going up by 2. Really, this is the best way to do it. If you rent 15 movies, that means x would be 15. So we would have y equals 1.5 times 15 plus 5. Over here, we would have y equals 2 times 15 plus 4. This one I can do without a calculator. This one would be 30 plus 4, so this one would be 34. So $34 for 15 movies. This one, I'm going to have a calculator for that. Okay. 1.5 times 15. Usually I have this all worked out in advance, but I didn't see this coming. Okay, so we would have 1.5 times 15 is $22.50. And then you would add $5 to that. So Company A would be charging you $27.50. All right. So how much more will Company B cost than Company A? All righty. We would do 34 minus $27.50, which I probably could have done in my head, but it's early. I'd probably screw it up. $6.50. Okay. There's a $6.50 difference. Okay. Now we have example 2. Again, too many words on the page. Seriously, this is a math book. Why are there so many words on the page? Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill costs 15 cents per minute plus an initial fee of $49. Benjamin's monthly cost is shown in the graph. Compare the functions. Okay, so what is the initial value of the function for Angela? What are they charging? What is their initial fee? That's $49. What is the initial value for Benjamin's bill? It looks like his initial value is $60. So Benjamin has a greater initial cost. What is the rate of change for Angela's bill? All right, Angela's paying 15 cents per minute, so that's her rate of change. Remember, rate of change is the thing that occurs over and over and over again. 15 cents for every minute. What is the rate of change for Benjamin's bill? So we would have to calculate the slope here. The cost goes up, what, $10 for every 120 minutes? So up 10 over 120. This works out to I did this one in advance, 0.10. He's paying 10 cents per minute. Verizon would have a heyday with this. Okay. Determine the monthly cost for Angela and Benjamin for 200 minutes. Okay. Well, what we've got is we've got Angela and Benjamin. Angela's equation is y equals 0.15x plus 49. Ben's equation is y equals 0.10x plus 60. And they want to know when x is 200, what will be Benjamin's cost, or what they want both of them. So we're going to substitute 0.15. We're going to substitute 200 minutes here plus 49. Okay, and then over here we're going to go 0.10 times 200 plus 60. Okay, and so we get that Angela, when we do the math there, we would get that Angela would pay $79 and Benjamin would pay $80. Okay. Fun times, right? I'm having a great time. Okay, now we're talking canoes. Now we're talking some serious fun. You and your friends want to go on a canoe trip. River Run Canoes charges an initial fee of $10 plus $10 per hour. The cost for Clearwater Canoes is represented by the graph. Which company has the greater initial value and which company has the greater rate of change? Okay, so we have River Run Canoes. Their equation would be they want $10 plus $10 an hour, so $10 per hour plus $10 up front. Then we have Clearwater, all right? Their rate of change, let's see, we go up 4, right 2. So if you go up $4 and right 2 hours, that's $4 every 2 hours. How much are they charging per hour? They're charging $2 per hour. But their initial fee is 16. Okay. Which company has the greater initial value? Well, the company with the greater initial value would be Clearwater. Has the greater initial value. And River Run has the greater rate of change. Determine the cost for each company if you want a canoe for 4 hours. Okay, so taking this one, we would substitute 4 for X. Taking this one, we substitute 4 for X. 10 times 4 is 40. So $50 for River Run. This would be 8 equals $24. Well, definitely Clearwater is cheaper. So if we're going to go for 4 hours, we want to go to Clearwater. Definitely. Right. Okay. All right. I think this is our last example too. Apply ebooks. Aisha is researching 3 different online book subscription companies. The cost Y of each subscription is a linear function of the number of books downloaded X. The prices for 3 different subscription companies are shown. Aisha plans to download 10 books and wants to spend the least amount. From which company should she purchase a subscription? So now we have 3 functions. How fun is this? Okay, they've got all this stuff over here, but you know what? That doesn't help me. Does not. Okay, so we have the bookshelf, which is the equation is given here, but we need an equation for We Reads, and we need an equation for Bookworm. All right. We Reads, what is the rate of change? Up by 1, up by 1, up by 1. How is this going up? Get the calculator out. No, I can probably do this in my head. 575. So it's 575 a book. That went up by 575. Okay. So 575 a book is We Read, so it's $5.75 per book. What is their initial value? Well, initial value is when X is 0, what's Y? Their upfront cost is $18. Okay. So that's for We Reads. Now let's look at Bookworm. What is their initial value? It looks like they don't have an initial value. What is their rate of change? Well, we went up 15, right 2. So they charge $15 for 2 books. So what are they charging for 1 book? $7.50. And there is no initial value, so there's no plus or minus over here. All right, so now we have 3 equations, and the bookshelf was given to us. It's Y equals 4.5x plus 20. Okay, well, let's see. She wants to download 10 books, and they want to know which one is going to be the cheapest. So you've got to go in and substitute 10 for X here, 10 for X here, and 10 for X here to figure out which one of these will be the cheapest service. Okay, easy peasy. 5.75 times 10 plus 18. Well, this would be 57.50 plus 18. Yeah, I'm not going to even try it. Yeah, handy dandy calculator. 57.50 plus 18. 75.50. Okay. This one, if we substitute 10, 750 times 10 is 75 bucks. So far, Bookworm's cheaper. We Reads is more expensive. But what about the bookshelf? If we rent or we read 10 books here, all right, 4.5 times 10 is 45. And 45 plus 20 is 65. Woo, doggies. Guess who's the cheapest? Bookshelf. Yep, Bookshelf is the cheapest. And I think, nope, that's not all there is. There's a check. Okay, so we have cell phone plans. Andrea is researching cell phone plans to determine which is the least expensive. The cost Y of each plan is a linear function of the number of months X that she has the plan. The prices for 3 different plans are shown. Andrea expects to stay on the plan for 18 months and wants to spend the lesser amount. Which plan should she choose? Okay, so from this problem, we're going to derive our secret word. Our secret word today is going to be cell phone. I know it's 2 words. Don't get technical on me. Okay, so I need a y equals mx plus b for this one. This is going up by 1, up by 1, up by 1. This is going up by 45. So the rate of change here is 45. And the initial value, when x is 0, y is 100. So the initial value for this one is 100. This is cell phone plan B. Cell phone plan C, the initial value is 0, but what's the rate of change? It's going up 120 for 2 months. So that means the rate of change is $60 for 1 month. So this one is y equals 60x, but there's no initial charge. There's no upfront fee. So what is the question again? She's going to stay on the plan for 18 months, and she wants to know which one's cheapest. Cell phone plan A, we have Y equals 50 times, well, how many months? 18 months times 18 months plus 50. Cell phone company B would be 45. I guess I should put the Y here, be consistent. 45 times 18 months plus 100. And company C, Y equals 60 times 18 months. Okay, so 50 times 18 months, gonna need the calculator. 50 times 18 is 900. And 900 plus 50 is 950 for company A. All right, this one we have 45 times 18 is 810. That'd be 810 plus 100 would be 910. That's company B. Well, we know we're not going with A. And 60 times 18 is 1080. Isn't that a video game? All right, so which company is the cheapest for 18 months? That would be company B. All right, remember the secret word was cell phone today, and I'm pretty sure that's all there is. Yep. Okay, so go on over and do the secret word assignment. Remember the answer is cell phone, and I will see you when we do the practice problems. Until then, guys, later.